So I've just basically started with the first thing I did was create a memory class. I'll show you that. And what it does is it has a byte array, and that will be the main memory. And then when you create it, it will set all the bytes to 0. You can load a bytes object. This will read from a file, for instance the BIOS. We'll put that in there, and then I've also created some print functions. And these print functions I will use to, to debug and to see what's in the memory at a given time. So next thing that I wanted to do is I wanted to create a way to load a Rom file. So basically I will say loading Rom, and then I'll need to load, I'll need to check if I'll need to check what's given. So just for good measure, I'll print out what the user gives to me. Argument supplied. I'll use a simple one. argv1. And then I'll try to load it in. argv1 mode. And you can read the mode stuff on Python documentation, but basically what this means is R stands for read and B stands for binary, which is useful because then it will read as single bytes and it will not try to decode it to UTF-8 or something like that, or Unicode. So that's useful. And this with function is also very nice because it allows you to basically, in this indentation, execute a bunch of commands, and then I don't need to manually close it because it will do that automatically for me. And I'll say something like ROM is FL read, and then I'll for now I'll just print what's what it's read. Because I don't actually know how to decode a ROM file yet. I don't know if there's some kind of standard for that, but we'll find out. And else no argument supplied. Oh yeah. This is just something I'm going to use later. I don't know if I'm going to need a separate class for this or not, but This should give me an error when I run it because I have not supplied a file name. Of course, I need def. Oh, what happened there? I need to init first because it will set my logging level. But what is going on here? It's doing nothing. I'm just going to check real quick how I need to read the arguments. Oh, I needed to do it another way. This sys.argv. What's going on here? That's annoying. Yeah, blah blah blah. How do I get those main arguments again? Let me think. I've done this a bunch of times, so check an import sys. I'm just doing it sys.argv. Maybe I need to lose the main function. Yeah, let's do that. yeah, so this is good. So it tries to read the file that does not exist that I gave it. So let's try it again with the real file. And it prints out the contents of that file, which is a lot of stuff. Let me just quickly change my terminal to maybe show you some bigger text. This is readable. So this should be better. And also, well, not limited. So a little bit more buffer. So now we've read the file. Now we can instantiate our ROM. So we're going to use this class here. And I think I'm going to do it like this. I'm going to say ROM is ROM. And what this gives me is a bytes object. It's a standard Python thing. Bytes, which is basically an immutable array of bytes. Yeah, so it's this kind of thing. Just same the byte array. This is something that's more useful for mutable objects. So these are mutable, and bytes is not mutable. And you can give it, you can do this kind of stuff. But I'm going to use it to input my ROM. And then I'm going to switch to my other terminal. ROM.py. So this is going to take data as input for now. So byte array, and the size, I don't know what the maximum size is of these ROMs. Let me check the documentation. It's a very complicated piece of documentation. I think this does have all the information, but so as far as I know this stuff, there are all kinds of different cartridges for the Game Boy. So you have old cartridges, new cartridges, you have cartridges with saving abilities, you have cartridges which are you cannot save anything to it. And I think the first one I'm going to use is Super Mario, and I don't think it has a saving capability, but I'm not sure how it works. But what I do know that it has I got it here, and it's 64K exactly. So I don't know really what I can do with that. Oh, sorry, just switching all over the place. This can go, and this one. Cart location 047. Maybe we can just look at the cartridge. DXX, Super Mario, XDV, DXX. I don't remember the. Yeah, XXD. So this is a handy program that I can use to check, you know, the binary data of the memory or the BIOS, or in this case a memory cartridge. So let me just check the documentation again. The following defines the byte at location 147. Okay. So at location, where's location 147? One, 2, 3, 4, 5, 6, 7. Oh, E147. Did not read that correctly. So this is what is at 14700. I don't know what it means yet. So let's take another look at the documentation. Okay, so it's only a ROM, or there's a memory bank controller. Other memory bank controller. Or it's a memory bank controller 5. We can have a rumble card. So maybe I'm going just to skip that for a little bit. Because one thing I need to work on, I know, which is the core CPU part. So all the instructions, we need to decode them and execute them, and you know, have a definition of what all the instructions do, and kind of want to get into that now. But first I need to, you know, set up the booting process so we can actually load instructions that we can, you know, decode, and so we can run our first instructions and run some tests, because that's a really important part of this, is decoding the instructions and making sure all of our instructions work. Then slowly we can work our way up to actually you know, getting a game to run and starting all the Game Boy boot sequences. Because something I haven't showed you yet is there is also a BIOS sequence, and that is what they're talking about here. There's a 256 byte program starting at memory location 0. The weird thing is I read something about the boot sequence, and if you see the little bit of code I have here, there's a BIOS.ROM, and I think that's this what they're talking about here, because it's a 265 byte program. But they say it's stored at C000. So do I need to copy that over to memory location 0 before executing it, or how does this even work? So okay, what this program tells me is the first thing the program does is read the cartridge location from 104 to 133 and place this graphic of a Nintendo logo on the top of the screen. This image is then scrolled until the middle of the screen and 2 musical notes are played. Again, the cartridge locations 104 to 133 are read, but this time they are compared with a table in the internal ROM. If a byte fails to compare, then the Game Boy stops comparing the bytes and simply halts all operations. So the way I read this is that this is an explanation of what that byte program does. It's not something that's extra coded into the system somehow. So what I think it does is it copies this location. It doesn't make sense to me, because how would it copy this piece of memory into the first bit of memory if no program is running? So in other words, what is at memory location 0 when I boot up the system? Oh, here's the definition of 147. ROM only, ROM plus memory controller 1. Okay, so if I look again at my Super Mario cartridge, and we look at memory location 147, if I'm doing this correctly, and please correct me if I'm not counting this properly, 1 byte, 2 byte, 3 byte, 4 byte, 5 bytes, 6 bytes, 7 bytes. So this is the 7th byte of this row, which means it's 0147. But that would mean that it is a 0, which doesn't make sense because it's a 64 kilobyte ROM, and sorry, if it's a 64 kilobyte ROM, it wouldn't fit, because I think the ROMs are only, they're not big enough. Oh, but in 148 it specifies this size. Okay, so that could make sense. So 148, as you saw, can go back to it. 148 is 0, 1. So that should mean that, according to this documentation, ROM size is 1. So it is a 512 kilobit ROM, which is a 64 kilobyte and holds 4 banks. So that would actually make sense now. So it is a 64 kilobyte program and it holds 4 banks. So what else is here? 149 RAM size. No, let's have a look at that. So this is 149 then. Is 1. So it has a 16 kilobit or a 2 kilobyte RAM on the cartridge itself. That's interesting. One bank of RAM. Maybe destination code. Let's have a look at that. 1 for A. 1 for... Oh, my cat is just jumping in front of the screen. 1 for A. 1, 2, 3, 4, 5, 6, 7, 8, 9. A 0, 0. So that would mean it's a Japanese destination code. Okay. licensee code. It's the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, 0. $33 means you have to check 144, 145 for license code. Okay, 144, 145. Zero, 1, 2, 3. Have I been counting wrong all this time? I think I've been counting wrong. Always count from 0.